Okay, if the previous lesson was the law of sines, this lesson must be the law of cosines. So, of course, law of sines helps us out when we had an angle and its corresponding side. But what happens if not only do we not have a right triangle, but we are also unable to use the law of sines? I'm so glad you asked. We are going to be using the law of cosines. That's going to save the day for us. All right. So there's my picture of my triangle. If I want to find either angle A or side A, this is what the equation is going to look like. If I want to find either angle B or side B, this is what the equation looks like. And if I want to find either side C or angle C, that is the form of the equation I need to use. All right, so let's get a picture up here. Make note that this is a side angle side, different than what we did with the law of sines. And what should I look for first? Well, take inventory of what I know. I'm like, well, I guess side A, right? Angle A is the clue. It's like, hey, the only angle I know is angle A. So this is the form of the equation I'm going to want to use. All right, plug in the values I know. Let's do the squaring and the multiplying using a calculator if need be. Now, combine like terms. I can add two of those numbers together, but now I've got no more like terms. All right, notice I'm not going to try to do 1,205 subtract 1,196, right? Those are not like terms. Instead, I'm going to have to grab a calculator, figure out the cosine of 114 degrees, plug that into the equation. Now I can multiply two numbers, and of course negative times negative comes out positive. Now I can add those numbers together. Notice it's very calculator driven. Finally, take the square root. And I come up with a little more than 41. If I round the nearest tenth, it'll be 41.1. Add that to the diagram. Now I do have an angle and its corresponding side. So now I can use the law of sines. All right, so if I want to find, maybe I want to find the angle B first. All right, this is from the previous lesson using the law of sines. Heavy use of the calculator, inverse sine function, and viola. There is my missing angle. Add it to the diagram. And of course, if I know two angles and I want the third angle, hey, it's a triangle. They got to add to 180 degrees. All right, I can't use Pythagorean theorem. I can't use SOHCAHTOA, but I can still use the fact that three angles must add up to 180 degrees. If you're wondering about that from the previous slide, I don't have a right angle. Therefore, there's no such thing as a hypotenuse. So if you're thinking the good old-fashioned SOHCAHTOA, remember that only applies to a right triangle. It does not work with an obtuse triangle. And if you're really wondering how an angle can possibly come out to be negative, hang around for pre-calculus. Sometimes we get far enough in second year algebra. This year we did not, though, so they're going to be waiting for a pre-calculus. Hey, this time it looks like side, side, side. Does it matter which angle I look for first? Aha. Why do I need to find angle B first? we got to take a little bit of a detour here. Let's look at what happens with angles that are a little bit more than 90 and a little bit less than 90. Specifically, angles that are 1 degree less than 90 and angles that are 1 degree more than 90. Notice what happens with the sine function. With the sine function, I get identical values. Look at the cosine function. Cosine function clearly knows when the angle is greater than 90 versus less than 90. The inverse sine function will not identify an obtuse angle, all right? It's blind to that, right? So the law of sines is not the method we want to use to find an obtuse angle. So if I have a choice with the law of cosines, I will always choose to find the largest possible angle because the law of cosines will not let me down. All right, so if I'm given free reign of which angle to go for first, I know because 6 is the largest side, the largest angle has to be B. That's what I'm going to look for first. Plug in the values for A, B, and C that we know. I can do my squaring, I can do my multiplying. Combine like terms. Well, the 16 and 25 will combine. No, you cannot do 41 subtract 40. Those are not like terms. Instead, let's subtract 41 from each side. Divide each side by negative 40. You can either leave it as 1/8 or you can convert it to decimal, 0.125. Angle B would have to be the inverse cosine of that value. It comes out to be 82.8 degrees when I round off the nearest tenth. So law of sines would not have been a problem there because that's an acute angle. Hey, I now have an angle and its corresponding side, so I can use the law of sines. So I'm going to go through this rather quickly because this is from the previous lesson. Of course, you can also pause the video or look at the PowerPoint without animation to see where that answer of 41.4 degrees is coming from. And then also quite quickly, if we know two angles, we actually know all three angles. And I can add that to the diagram. Okay, so let's go for the more exciting situation here. Gee, I wonder what's going to happen this time if I use the law of cosines. Well, this again is a side situation. And so I'm going to go for the largest angle. Since 11 was the largest side, B will be the largest angle. Plug in the numbers I know. I can square them. I can do the multiplication. Combine like terms. Again, I cannot do 85 subtract 84 because the 84 has a cosine of B hanging onto it. So instead, I'll subtract 85 from each side because I want to get that cosine of B isolated. Divide each side by negative 84. And I got some weird decimal. I kind of rounded it off there. Inverse sine. Oh my goodness, an obtuse angle. Right? The law of sines would not have recognized that. Thank goodness for the law of cosines. Okay, again, now I've got an angle and its corresponding side. I can switch to the law of sines, which was the previous lesson. Plug in the numbers I know, do my multiplication, do my inverse sine. There's the missing angle. And again, if I know two of the angles, I automatically know the third angle because they've got to add up to 180 degrees. Add that to the diagram. And viola, we've got. So we started out with a bunch of rocks, and now here's a slab of rock. If we take a chisel and dig through it, oh my goodness, what a shock. The amazing secret word is worksheet. Never would have guessed that, huh? And, well, that was kind of real pretty and exciting. Let's look at a slightly more scenic picture of rock. Right, nice little rock outcropping in front. Some gorgeous mountains in the background. And it's probably time to get to work.